I'm Kike, founding product manager at Galileo, and today I'm going to be talking about how you can evaluate your agents using Galileo. But before we get there, we'll spend a couple of minutes talking about what an AI agent is, why evaluating agents is so difficult, and finally, we'll talk about how Galileo can help. So, what is an AI agent? Agents is probably one of the most trendy buzzwords in the world of AI, and very often it gets misused. For some, agents are fully autonomous systems able to operate independently and use various tools. Others use the word agent to describe predefined workflows. Here at Galileo, we subscribe to the view of our friends over at Anthropic. We differentiate between workflows and agents. A workflow is a system where the LLM and tools are orchestrated through predefined code paths, where the sequence of events that take place is defined and hard-coded into code. A traditional RAG system would be considered a workflow, whereas agents are systems where the path is non-deterministic and gets chosen by LLMs. Because agents are able to determine their own path by deciding which tools to call and how to handle a request, this allows agents to handle a wide range of tasks. And the agentic architecture turns one-trick pony workflows into multifaceted complex systems capable of even replacing humans in certain situations. While there are many different frameworks and architectures of agents, at the core, they all follow a flow that looks something like this. When a user input comes in, an LLM planner decides how to handle it. It has a couple of different options available. It might call one of its tools, one of the tools that it has access to. It might call one of the agents it has access to, or it might respond right away back to the user. When a tool or agent gets called, the output of this is usually sent back to the LLM planner, which, again, using all the information available, decides, once again, what the best next action is. And this process is repeated until the LLM planner decides that it's time to respond back to the user, either because it's done completing the ask, because it can complete the ask, or because it just needs more information. Now, this flow here might look simple, but it can get really, really complex as you start giving more and more functionality to your agents. And as you start building these complex and powerful systems, it's really important to be able to tell whether they're working correctly. A system that can choose its own course of action, that has access to a wide range of tools and APIs, which can have real side effects in the real world, is a system that needs to be tested thoroughly. Yet this is easier said than done. After talking to hundreds of developers building agents, we've identified a few patterns of the challenges that they face. Again, agents follow a non-deterministic path, and that's a core aspect of agents. The big challenge of agentic evaluation is one, understanding the path that was taken, and two, evaluating whether that path was the correct one. And because these paths have gotten really, really complex and long, the number of failure points has increased. And finally, balancing cost and latency with performance and being able to make that trade-off in a scientific and systematic way remains a big challenge for most developers. Let's go back to that flow diagram for a second and look at all the different potential failure points. Every time an LLM planner chooses what to do next, there's a chance that it might be making the wrong choice. Maybe it picks the wrong tool, sets the wrong arguments. So when evaluating your agent, understanding whether the correct tools and arguments were selected is super important. Then every time a tool gets executed, whether it's making some API call, executing some local code, or even calling another agent, there's a chance that things go wrong. Systems fail, integrations aren't always that well documented, and user errors happen. So when evaluating your agent, detecting any errors in your tools and finding patterns in these tool errors is critical to debug said agent. And finally, once the agent returns, it's critical to measure whether the user was able to meet their goals. None of the rest matter if the agent isn't able to accomplish the user's goals. All right, so how does Galileo help here? Galileo's agentic evaluation platform helps you evaluate your agentic system, whether you're building, shipping, or scaling it. We offer end-to-end visibility into your agents. You can trace every step or span your agent takes and understand the path that was taken. Not only see the final response, but also see the inputs and outputs of every step or span of your complex system. We've also built a set of agent-specific metrics. These metrics are backed by research, and they allow you to measure both the end-to-end success of your agent as well as identifying specific failure points. And with cost and latency tracking built in, you can make that trade-off between cost, latency, and performance, understanding how your choices will impact your end users. Let's take a closer look at the metrics that I was talking about. We're announcing 4 new agentic metrics. These 4 metrics are tool selection quality, a metric that detects whether the correct tool and arguments were called. Tool errors, a metric that detects whether any individual tool in your agent errored out. Action advancement, a metric that detects whether the user was able to advance towards their ultimate goal. And action completion, a metric that detects whether the user was able to accomplish their goal. Each of these metrics is geared to detecting the different failure points in your agentic systems. Action completion and advancement help you understand whether at the session or trace level, the user was able to accomplish or advance towards their goal. And when these metrics are low, it's a sign that something went wrong in the system. And tool selection quality and tool errors help you pinpoint and debug exactly why things went wrong, so you can go back to your code and fix them. These 4 metrics help you understand your agent at different levels. Tool selection quality and tool errors help you detect issues at the spans or steps of your system. Action advancement helps you detect whether certain traces or turns in your conversation are contributing and advancing towards the user's goal. And action completion measures at the session level whether the user was ultimately able to accomplish their goal. These metrics join our Luna evaluation suite, a family of research-backed metrics built for GenAI evaluations. We're strong believers that you need to be able to measure things in order to improve them. And you can't measure things without metrics. So one of our pillars and one of the core focuses of the team is to build and provide you with the best metrics and tools to evaluate your systems. Okay, enough talking. Let me demo how you can use Galileo to evaluate your agents. Okay, so I've trained a chatbot to power the booking system of my food ordering application called EatGood. And this agent is able to do the things that you would expect a food ordering application to do. It's able to look up restaurants like cuisine. It's able to look up the menu of a restaurant. It's able to get the ingredients. Of course, it can order food and cancel orders. Now, I've built this agent and I've already played with it a little bit in my sandbox environment. But now I want to run a systematic evaluation. I want to run a series of queries through it to see how it performs. Now, I won't go over my entire notebook, but let me show you a couple of things. I've built this agent using LangGraph, and it's a simple agent that follows the same flow that I showed earlier. Now, these are the tools that the agent has at its disposal. It can do a web search, it can find restaurants on the platform, it can get the ingredients for them, it can get the menu, it can, of course, order food, and the things that you would expect. Now, again, I've built this, and And I've run an evaluation over my entire evaluation set. And these are a number of queries that are representative of what I expect this agent would get in production. And as part of my evaluation, I've logged everything to Galileo, of course. So at the end of this notebook, I get taken to this dashboard, my evaluation run. Now, the main views, you have a table with all the traces, where each trace corresponds to a query in your eval set. Each trace is, of course, augmented with our metrics, which help you identify errors and bugs in your system. On the left, you see alerts. This is the summary of things that we've identified that could be potentially wrong with your system. They also serve as shortcuts into specific errors. When you open a trace, you see every step that took place. You can also see how long each step took and how much it cost you. And if you click onto them, you can see all the inputs and the outputs of that step, along with the metrics that were calculated for that step. Now, let me show you how you can use our new metrics to detect issues in your agent. So as we can see on the dashboard here, we already have some reds. Let's look into the first one. So the first scenario is we're trying to order a deep dish pizza from the restaurant called Buddy's. And the agent first asks that LLM planner, hey, the user wants to do this, what should I do? And the LLM planner decides to call the tool order food on eatgood.com with the restaurant Buddies and the menu item deep dish pizza. Now, this tool fails, and this is detected by the tool error metric. And as you can see, the tool fails because the restaurant is not available on eatgood.com. Now, this is one scenario that I'm probably not handling well in my application, or maybe I need to make sure that before I order something from a restaurant, it has to be available on the platform. So I've already identified one issue with my system, and as I find things, and I'm working on this agent, of course, with my team members, and I'm not alone. I want to annotate and just share my findings with the rest. So I can go into the annotations tab and add an annotation. And of course, I can configure this and add any type of annotation here that I want. So we can say something like quality and make this a 5-star thing. And as I go through my evaluation run, I can annotate all my traces using the same rubric. So let's go ahead and say that this one was a problem with the booking flow because we were trying to book and it couldn't. Now, all right, let's look at the next one. So there's a red action advancement here. Let's look at what's going on here. Here the user is asking to cancel because they're allergic to ginger. Okay. And if we look into the LLM step, we can see maybe that previously, before this turn, we had just ordered a couple of pieces of sushi, and one of them contained ginger. It looks like the gyoza contained ginger. Now, this user is apparently allergic. They just realized and they want to cancel. Now, the response of the LLM is, I don't know how to cancel the order. And the action advancement metric caught this because, of course, it's realizing, hey, the user wants to cancel, and this agent is not really doing it nor advancing towards canceling the order. And actually, if we look into the explanation, we can see that the bot had access to a series of tools, but no tool for canceling an order was listed. So it looks like the issue here at hand is that when I wrote the code for my agent, I might have forgotten to include the cancellation tool, or in this case, the LLM didn't have access. But we can always go here into the LLM step, look at the inputs that it had available. You can see all the tools that it had available. And we can see that, okay, there's finding restaurants, getting menus, ordering food, but no cancellation tool. So of course, this agent or this LLM didn't have the ability to cancel the order for the user. Now let's look at one final one. Let's look at this one. So it looks like this one had both an action advancement issue and a tool selection quality. So what I think happened is the user tried to do something, it couldn't, and the problem is probably due to the tool that was selected. So it looks like the user's, again, trying to cancel something, and the response is that the cancellation was not successful because okay, so let's look into this. We can look at the action advancement and we'll see, of course, that, we actually have an explanation here. So the tool attempted to use the cancel on itgood.com tool, but it incorrectly used the order ID as the user ID. And if we go into the tool that was predicted, we can see that the tool selection metric probably told us a very similar thing. And if we scroll down, we'll see what the LLM predicted. And sure enough, it's saying, hey, call cancel, which is the right tool to call, but it's using the wrong args. It's passing user ID instead of order ID to cancel the order. So this is 3 examples of how you can use these 3 new metrics to detect issues in your agents. Now, of course, we found 3 things that are wrong with the system. I can go back to my notebook, fix them, and rerun this evaluation until I see that my agent is ready for production. I hope that you enjoyed this demo, and I can't wait to see what types of agents you build. Thank you.